So now we will talk about different kind of matrices. Some of the matrices we have discussed just few minutes ago, and we will revise them and we'll talk about different kind of matrices. So we know about a special matrix called null matrix. It is also known as zero matrix, and as it is obvious from its name that this matrix has what?
All zeros.
The matrix has all zeros. So I'm just making all the matrices of 3 by 3 dimension, and you can generalize it for any dimension. So now this matrix has all zeros. In this case 9 zeros, because it is 3 by 3 matrix. It has 3 rows and 3 columns. Similarly, we have talked about another matrix called identity matrix. But in case of, if we have to talk about, this is also identity matrix, but we call it as additive identity. That means it is identity in case of addition operation. But when we doesn't say additive identity, we just say identity. And we doesn't mean this matrix. We mean multiplicative identity. So if I say identity only and I doesn't say additive identity, then it means multiplicative identity. So now second our matrix is identity matrix, or we can say it's multiplicative identity matrix. Here this was additive identity matrix, but I have not written identity. So now what kind of this matrix will be?
Multiplication.
So what will be the entries of this matrix?
In diagonal or anything, and all the other will be zeros.
No, in diagonal will not have anything. Diagonal will have only ones.
Only one.
So it will have 1, 1, 1, and rest of the entries are zeros. So now we also know about another matrix, right, which is diagonal matrix. Now in this case, diagonal can have anything. Diagonal can also have some zeros, but if it has all zeros, it will become obviously null matrix. But it can have some zeros, right? But diagonal can even have 1. This is also a diagonal matrix, but it will only have non-zero entries in the diagonal. So like diagonal can have A, B, C, with A, B, C can take any values like -1, 0, 1, blah blah blah, and all rest of the entries will be zeros. And this is the diagonal matrix. Identity matrix is also a diagonal matrix, but it is a special kind of diagonal matrix where A, B, C are equals to 1. So now we also revise some more stuff about matrices, but before that maybe talk about some more types of matrices. We also have square matrices, right? Square matrices. So now we have square matrix. A square matrix is a matrix whose number of rows are same as the number of columns. Like these matrices that I am writing here was a square matrices because they are 3 by 3 matrices, right? So we have a square matrix. That means a matrix whose dimension is what? N by
N.
N by N. That means the
Same
number
rows,
of
same
rows
columns.
is equals to number of columns. Very good. And now we also have another matrix called triangle matrix. Now we have two kinds of triangle matrix. One is upper triangle matrix, one is lower triangle matrix. So we have like triangle matrix, but we can say one is upper triangle matrix, upper triangle matrix. Because I'm lazy, so I'm not writing here triangle, I'm just drawing triangle. It's difficult to write but easy to draw. And the other one is what? Lower triangle matrix. Right? But if this is not the proper figure of upper triangle, the proper figure of upper triangle is this. That means this is a matrix whose entries in the above half of the matrix are non-zeros, where all zeros in the lower half. So like this is a square matrix whose entries in the upper half can be non-zeros, where all entries in the lower half will be zeros. And how to draw a lower triangle? We can say like this. This is a square matrix whose entries in the lower half can be non-zeros, but all the upper half is zeros. So we have a 0 here, and here we have non-zeros. So let's make a upper triangle matrix of 3 by 3, just to make everything clear. So in this case, so let's first draw a triangle, upper triangle in it. So we have here our diagonal, the main diagonal, and this is our upper triangle. And this is a 3 by 3 matrix, so it can have, in diagonal it can have any entries, so I can write here maybe 1, 2 and 3, but lower half will have all zeros, so I have this here 0, 0, I will have here 0, right? This is the lower half, and the upper half I can have any known zeros elements, right? So I can have here like 1, I can have here maybe 2. And this matrix is an upper triangle matrix because all the entries in the upper side of the matrix are non-zeros and the lower side is zeros. Yes?
You missed one number.
I missed
Second
here?
row, yes.
Very good. Thank you very much. Very good. Good catch. Right? So I write here 1 again because I am lazy and writing 1 is the easiest. Otherwise you can write anything else here if you are not lazy like me. So now we have to draw a lower triangle matrix. In the lower triangle matrix we have once again a diagonal and now everything below the diagonal can be non-zero, but everything above the diagonal is 0. So this is the lower triangle matrix. So let's say in the diagonal once again I'm writing example of 3 by 3 matrix, and I encourage you to write example of 4 by 4 matrix, or 5 by 5 matrix by yourself. Maybe make a art out of those matrices, right? So make a beautiful art out of those matrices and show me that art. So now I have here maybe 1, 2 and 1, and then I can have all the entries above zeros, 0, 0, I have here 0. If I have not missed anything, because, and then I can have here non-zeros entries, but it doesn't have to be all non-zeros. Some can be 0. So this can be 0. It will still be upper triangle matrix. So these entries can be zeros or non-zeros, right? So I can have here what? Let's say I have here 0, I have here 1, and 1, 2. I have here one more entry which is like maybe 5. I don't know why this is here. It should be like here. I think this is done, right?
Yes.
I missed anything?
Nope.
No, this time I have not missed anything. So now we have learned about how many types of matrices. 1, 2, 3, 4, 5, 6 types of matrices. All right, make sense?
Yes.
So that's it for this video. See you next time, and we continue with our matrices. Maybe next time we will find inverse of a matrix. Inverse of what matrix? Not the additive inverse that we already know how to find. What kind of inverse we want?
Multiplicative.
Multiplicative inverse, yes. So see you next time.
Bye.
Bye.